Okay, hello grade 11s. So today what we're learning about is trigonometric ratios for special triangles. Now, we have two special triangles, and basically special triangles, you have to memorize their angles and their side lengths. Our first special triangle is the 45-degree angle triangle, and this is a right isosceles triangle. So let's take a look at that one. What I mean by a right isosceles triangle is that it has a right angle. Oh my goodness. It has a right angle, okay? And it's isosceles, meaning that two of the sides are the same length. So we call these sides legs. If this leg is equal to 1, then this leg would also be equal to 1. Because our two side lengths are the same, our two legs are the same length, okay, and the angle in between them is a 90-degree angle, that would leave our other two angles to be 45 degrees. To figure out what our hypotenuse would equal, okay, so this is our hypotenuse, we just have to use Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. In this case, our two legs are 1 squared and 1 squared. So 1 squared plus 1 squared, we end up with 2. And to get c by itself, we have to take the square root of 2. So our hypotenuse is actually equal to the square root of 2. And this is our first special triangle. You will have to memorize the angles and the side lengths. Okay, the other special triangle that we have to remember is the 30-60 triangle. And this 30-60 triangle actually comes from an equilateral triangle. So by equilateral, I mean all the sides are the same. So if our first side is 2, the other sides would also be 2. If all sides are the same, we know that all angles of a triangle add up to 180. So if we were to divide 180 divided by 3 angles, we would get 60. So in an equilateral triangle, the angles are all 60 degrees. Now, we don't care too much about this triangle. What we want is this triangle in half. So when we split this triangle in half, we're left with what we call our 30-60 triangle. So I'll redraw the 30-60 triangle over here. So this angle remains 60 degrees, but this angle becomes a 90 degrees, and the angle up top will be 60 degrees divided by 2, which of course is 30 degrees. Now, this side length remains as 2, but the side length on the bottom will be this side length divided by 2. So 2 divided by 2, which of course is 1. And we call this side length, so this one that's measured as 1, we call this the short leg. Our side length that's 2 is called our hypotenuse. It's always called our hypotenuse. The remaining leg, the one that's over here, is called our long leg. Now, to figure out what the long leg would actually be equal to, if our short leg is 1 and our hypotenuse is 2, we would use Pythagorean theorem again. So we would have 1 squared plus, we can call this b squared equals 2 squared. Okay, so that's from our Pythagorean theorem. We would bring the 1 squared over. So b squared equals 2 squared minus 1 squared. 2 squared is 4, 1 squared is 1. We end up with b squared is equal to 3. To get b by itself, we would take the square root of both sides. So our long leg is actually equal to the square root of 3. This is our second special triangle, where the short leg is equal to 1, the hypotenuse is equal to 2, and the long leg is equal to the square root of 3. Okay, this is our 30-60 triangle. So these are the two triangles that are special, and you do need to memorize the angles and the side lengths, okay? Now, the reason why we care so much about these special triangles is because they give us very important trigonometric ratios. And these ratios are exact. So you know when we usually solve for like sine 45 or cosine 45 and we get a decimal? Trigonometric ratios from the 45-degree angle triangle and the 30-60-degree angle triangle actually will give us exact answers, and they will be in fractions for most of the time. And I'm going to show you exactly how we would get some of these ratios. So what I like to do with questions like this, basically what this first question is asking us is, what would sine at 45 degrees be as a trigonometric ratio? Sorry, I'm writing this wrong. So we could put into our calculators sine at 45 degrees and get 0.707106781 blah, blah, blah. But in order to get a more accurate answer, an exact answer, we use these special triangles. So right now we're looking at a 45-degree angle. So we know that we're going to look at the 45-degree angle special triangle. So I like to just draw it off to the side. I know that both of these angles are 45 degrees. Now, according to my 45-degree angle special triangle, this leg is 1, this leg is 1, and this leg is the square root of 2. Okay? Now, I need to go back to SOHCAHTOA, all right, and think, how am I going to find sine at 45 degrees? So let's say I'm looking at this 45-degree angle. It doesn't matter if you're looking at this one or if you're looking at this one, you're going to get the same answer. But let's look at this 45-degree angle. How would I figure out what sine of that angle is? Well, I know that sine is opposite over hypotenuse, so let's go ahead and label this opposite. This is my opposite side. This is my hypotenuse side. Okay, this is my adjacent. So if I were to write opposite over hypotenuse of this special triangle, I would write 1, that's my opposite, right, over the square root of 2, right? That's my hypotenuse. Now, I don't know if you guys remember going back to, I think it was Unit 3, where we were talking about square roots and radicals, and how we don't like having a radical as the denominator. So all you have to do to get rid of a square root in the denominator is just multiply it by itself in the denominator and in the numerator. So technically this answer is correct, but mathematicians don't like having square roots in the denominator. So when we multiply the numerator and the denominator by the square root of 2, what we end up with in the numerator is 1 times the square root of 2, which is the square root of 2, over the square root of 2 times the square root of 2, which is just 2. So this is our exact ratio of sine at 45. Let's do the same thing for cosine at 45. So we're still looking at this angle, but cosine is adjacent over hypotenuse. So adjacent in this case would be 1 over my hypotenuse, which again is the square root of 2. Because I don't like having the square root in my denominator, I would multiply the numerator and denominator by the square root of 2. So my trig ratio, my exact answer for cosine 45 would be the square root of 2 over 2. Let's do the same thing for tan. Okay, so we're looking at tan 45. Now tan is opposite over adjacent, so my opposite, according to this special triangle, is 1 over my adjacent, which is also 1. So I can simplify that to 1. So the exact answer for sine at 45 is the square root of 2 over 2. And if you put that into your calculator, the square root of 2 divided by 2, you will get 0.707 blah, 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 which is what we got in our calculators earlier when we typed in sine 45. The exact answer for cosine 45 is the square root of 2 divided by 2. And the exact answer for tangent at 45 is 1. We all know that sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When we're talking about cosecant, we know that this is the reciprocal of sine, right? So instead of it being opposite over hypotenuse like sine is, it's actually, oh my goodness, hypotenuse over opposite. Same with secant, it's the reciprocal of cosine. So instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. Finally, with cotangent, instead of it being opposite over adjacent like tangent is, we know that cotangent is the reciprocal, so it'll be adjacent over opposite. So I went ahead and redrew the 45-degree angle special triangle. Again, you guys are going to have to memorize this. Let's figure out what the trig ratio for cosecant, secant, and cotangent would be, according to this 45-degree angle special triangle. So cosecant, let's label all of our sides. So we know this is hypotenuse, we know this is opposite, and we know this is adjacent. Cosecant is hypotenuse over opposite, so that would be the square root of 2, right? That's our hypotenuse, over our opposite, which is 1. And we can simplify that to just the square root of 2. So this is our exact answer for cosecant at 45-degree angle. So we know we're looking at the 45-degree angle special triangle here. Secant would be hypotenuse, which is the square root of 2, over adjacent, which again is 1. So the exact answer for secant at 45-degree angle is the square root of 2. And then finally, let's figure out cotangent, which is adjacent over opposite. Adjacent we can see is 1, and opposite we can see is 1. And we can simplify that, of course, to just 1. So what we just did was we figured out the exact trigonometric ratios for sine, cosine, tangent, cosecant, secant, cotangent at 45 degrees. And of course, this is based on our special 45-degree angle triangle. What we are going to do now is look at our 30 degrees and our 60 degrees. So for our 30 degrees and our 60 degrees, we are working with the 30-60 triangle. Okay, so let's go ahead and redraw that over here. Our 30-60 triangle, we've got 30 degrees here, we've got 60 degrees here. Right now we're just working with the 30 degrees, but it helps us to draw it if we draw out the entire triangle. Okay, and looking at this special triangle here, we can see that the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. So remember, you are going to have to memorize this. So the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. Now, because we're dealing with 30 degrees, I'm just going to go ahead and erase that 60 so it doesn't confuse us, but it is still 60 degrees. All right, so looking at the 30 degrees, our hypotenuse would be 2, our opposite would be 1, and our adjacent would be the square root of 3. Okay, let's talk about sine. Sine is opposite over hypotenuse. So in this case, we would have 1, which is our opposite, over 2, which is our hypotenuse. So that's the exact answer for sine at 30 degrees. And if you went into your calculators and typed in sine at 30 degrees, I'm going to do it right now, you will get 0.5, which is a half. So that's the exact answer, or the trigonometric ratio for sine at 30 degrees. Let's go ahead and do cosine. So cosine is adjacent over hypotenuse. So we have the square root of 3, because that's our adjacent, right? Divided by the hypotenuse, which is 2. There's our exact value for cosine at 30 degrees. For tan at 30 degrees, we're going to have opposite over adjacent. So opposite is 1, and adjacent is the square root of 3. Now, this is technically the correct answer, but as mathematicians, we do not appreciate having a square root in the denominator. So to deal with that, we will just multiply the denominator and the numerator by the square root of 3, and we will get the square root of 3 in our numerator, and then just 3 in our denominator. So that's the exact answer, the trig ratio for tan at 30 degrees. Our reciprocal trig ratio, I'm going to go ahead and draw the 30-degree triangle again, the 30-60 triangle, where our short leg is 1, our hypotenuse is 2, and our long leg is the square root of 3. This is our 30-60 triangle that we got from up there and that we probably have already memorized by now. Okay, cosecant is hypotenuse over opposite. So if we're looking at, let's erase the 60 so as to not confuse ourselves. If we're looking at the 30 degrees, my hypotenuse is here, my opposite is here, and my adjacent is here. For cosecant, we know that the ratio is hypotenuse over opposite. So we can see that our hypotenuse is 2 and our opposite is 1. So of course we can just simplify 2 over 1 to 2. For secant, our ratio is hypotenuse over adjacent, so that would be 2 over the square root of 3. But again, we don't like having the square root in our denominator, so we would multiply both the numerator and denominator by the square root of 3. What we will end up with is 2 times the square root of 3 divided by 3. And then finally, for cotangent, we know that the ratio is adjacent over opposite. So adjacent is the square root of 3, and opposite is 1. So we can, of course, simplify this to just the square root of 3. We just found all the ratios, the exact values of our trig ratios for sine at 30 degrees, cosine at 30 degrees, tan at 30 degrees, cosecant at 30 degrees, secant at 30 degrees, and cotangent at 30 degrees. Let's continue looking for our trig ratios, but at 60 degrees. Instead of looking at the 30 degrees in our special 30-60 triangle, we're actually going to be looking at the 60-degree angle in our 30-60 triangle. So we're looking at this angle now. So we know that sine, well, let's go ahead and change these because they're not the same anymore. Okay, the values are the same, but of course the adjacent switches with the opposite when we look at a different angle. According to this angle, my hypotenuse stays the same, it's still that one, but now my opposite is the square root of 3 and my adjacent is 1. So I'm looking at sine, which is opposite over hypotenuse. My opposite is the square root of 3 and my hypotenuse is 2. So that's the exact value for sine at 60 degrees. For cosine, it's adjacent over hypotenuse, so my adjacent is 1 and my hypotenuse is 2. So there you go, there's the exact value for cosine at 60 degrees. And then, of course, tangent is opposite over adjacent, so opposite is the square root of 3 and adjacent is 1, which we can, of course, simplify to just the square root of 3. So there's the exact value for tan at 60 degrees. Let's move on to our reciprocal trig ratios. So again, we're not looking at the 30 degree anymore. It's still the same triangle. We're just looking at a different angle. Instead of the 30 degrees, we're looking at the 60 degrees now. Okay, which would mean that our adjacent now has switched with our opposite. This is now our opposite, and this is our adjacent. Okay, so same as all the other times, cosecant is hypotenuse over opposite. So my hypotenuse is 2. Wow, what is going on? My hypotenuse is 2, and my opposite is going to be the square root of 3. Now, again, we don't like having a square root in our denominator, so we multiply both the numerator and denominator by the square root of 3. In our numerator, we're going to end up with 2 times the square root of 3, and in our denominator, we're just going to have 3. Okay, so this is the exact ratio for cosecant at 60 degrees. Secant at 60 degrees, we know that secant is hypotenuse over adjacent, so hypotenuse is 2, adjacent is 1. Okay, we simplify that to just 2. That's our exact value for secant at 60 degrees. And lastly, we've got cotangent, which is adjacent over opposite. So adjacent is 1, Opposite is the square root of 3. We don't like the square root in our denominator, so we multiply numerator and denominator by the square root of 3. We're going to end up with 1 times the square root of 3 in the numerator. That's just the square root of 3. And in our denominator, it's just 3. So grade 11's, these ratios, like this table, will not be given to you. You have to memorize the two special triangles, the 45-degree angle triangle and the 60-30 degree special triangle, in order to figure out what the exact values of sine, cosine, tangent, whatever, is at that angle. Okay, so just the 45, 30, and 60 special triangle. So the reason why these are useful is because it gives us the exact values. It doesn't just give us decimals, it gives us the exact values of questions that ask for things like, what is sine at 45 times cosine at 45 minus sine at 30? Normally, and in the past, when we've answered questions like this, we just get a really long decimal. But now we can actually get an exact answer. The way that we'll solve a question like this is we actually need to figure out what the ratio of sine 45 is, what the ratio of cosine 45 is, and what the ratio of sine 30 is. So let's get started with just what I do is I redraw my special triangle. Okay, let's start with the 45. The legs are 1. The hypotenuse is the square root of 2. I'm looking for sine at 45. I mean, I could just technically look up here, and I know that sine at 45 is going to give me the square root of 2 over 2, right? But you're not going to have this chart with you on the test. So what you have to do in this case, when you're just given a question like this, is draw out the triangle as I have, and let's figure out together what sine 45 is. So we know that sine is opposite over hypotenuse, okay? So if we're looking, we can look at either of these 45-degree angles. So let's just look at this one. My opposite would be 1. And my hypotenuse would be the square root of 2, right? Now, we don't like working with square roots in the bottom, so when we multiply both by the square root of 2, what we end up with is square root of 2 in the numerator over 2 in the denominator. So this section over here, sine 45, is the exact value is equal to the square root of 2 over 2. Now that's going to be multiplied by cosine at 45 degrees. When we look at what cosine at 45 degrees is, it's the same as sine at 45 degrees. That's the square root of 2 divided by 2. Now let's figure out what sine at 30 degrees is. Technically, we could go back to this chart and see that sine at 30 degrees is going to equal a half. Okay, but if we didn't have that chart, and you won't have it on your test, we would draw the 30-60 triangle, where the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. So if we're looking at sine, it's opposite over hypotenuse, okay, which is 1 over 2. So what we just did is we rewrote our sine, cosine at 45 degrees and our sine at 30 degrees as exact values. So they're no longer just decimals, they're exact values. Okay, and from here it's pretty easy, you just evaluate. According to BEDMAS, we have to multiply before we subtract, so we're going to multiply the numerator times the numerator and the denominator times the denominator. Okay, the square root of 2 times the square root of 2, it cancels out that square root, so it's just 2. Or if you wanted to look at it differently, we could say that the square root of 2 times the square root of 2 looks like this, right? Which then 2 times 2 is 4, and the square root of 4 is 2. Okay, so the square root of 2 times the square root of 2 is just 2. And then the denominator, we've got 2 times 2, which is 4. And that's minus the half. You guys should all know what to do here. We're subtracting fractions. We need the denominator to be the same And the lowest common denominator of 4 and 2 is 4. So we multiply this by 2. Look what ends up happening. We end up getting 2 over 4 minus 2 over 4, which of course is 0. Let's take a look at question B now. So we've got 1 minus sine 30 divided by cosine at 30. So we need to figure out what the ratio for sine at 30 is and what the ratio for cosine at 30 is. Okay, I actually have the triangle already drawn over here. So sine at 30 is opposite over hypotenuse. Okay, opposite over hypotenuse, so that's 1 over 2. Okay, and then that will be divided by cosine at 30. So cosine is adjacent over hypotenuse. So my adjacent here is the square root of 3, and then my hypotenuse is 2. This is sine at 30, this is cosine at 30. Again, we could have looked back at this chart and just seen that sine at 30 is 1 over 2, and cosine at 30 is the square root of 3 over 2. But you guys need to know how to do it. From here, we have to evaluate this division. Okay, to divide fractions, we know that it's keep, change, flip. So we can rewrite this as 1 over 2 times 2 over the square root of 3. Now that it's multiplication, we can multiply the numerator times the numerator and the denominator times the denominator. 1 times 2 is 2, and 2 times the square root of 3 is 2 times the square root of 3. Okay, this we can cancel out, it simplifies. It will simplify to 1 over the square root of 3 because the 2 cancels out. Now to completely simplify this, we need to put our 1 over 1. We can rewrite this so that there is no square root in the denominator. So that will leave us with the square root of 3 as our numerator and just 3 as our denominator. The lowest common denominator now is just 3, so we're going to multiply this by 3 and this by 3. So we're going to have 3 over 3 minus the square root of 3 over 3, which equals 3 minus the square root of 3 all over 3. Okay, and that's your answer for this question. Okay, and the last question that we have on this page is 3 times sine 60 times tan 60. So that 3 stays on the left there. We need to figure out what the ratio for sine 60 is and what the ratio for tan 60 is. The ratio for sine 60 we can find from this triangle, or we can find from this chart. Sine at 60 is the square root of 3 over 2. And again, if you don't know how we found that, we're looking at this angle here. Sine is opposite over hypotenuse, so opposite over hypotenuse, that's the square root of 3 over 2. Okay, let's do the same for tan at 60. So tan at 60, we know that tan is opposite over adjacent, so that would be the square root of 3 over 1, which we can just simplify to the square root of 3. And from here on out, we just evaluate. So we can put this above 1 and we can put this above 1. We're going to multiply all of our numerators and all of our denominators. Okay, so 3 times the square root of 3 times the square root of 3. Well, we can leave this as 3 for now. We know that the square root of 3 times the square root of 3 just gives us 3, right? And in the denominator, we have 1 times 2 times 1, which of course is just 2. 3 times 3 is 9 over 2. Okay, here we've got a left side equals right side question. So what we're asked is prove that sine at 30, gives us the angle here, prove that sine at 30 divided by cosine at 30 is equal to tangent at 30. So again, we need to look at our ratios. We can either draw them out which you will need practice with because that's how you'll solve it on a test, or we can just look at our ratios over here. Sine at 30, we know, is a half, and cosine at 30 is the square root of 3 over 2. I'll show you how we would figure that out if you didn't have that chart. We know that it's opposite over hypotenuse. So in this case, here's my opposite, here's my hypotenuse, here's my adjacent. It would be 1 over 2. Okay, so sine at 30 is 1 over 2. So cosine at 30 is adjacent over hypotenuse. So it would have the square root of 3 over 2. Okay, that's my adjacent over my hypotenuse. So sine at 30, which is 1/2, we're dividing it by cosine at 30, which is the square root of 3. Whoa, the square root of 3. Can it stop? The square root of 3 over 2. Okay, and we're trying to prove that this is equal to tan at 30. So this is my left side. I'm trying to prove that it equals my right side, which is tan at 30. So let's go ahead and figure out what tan at 30 is. So tan is opposite over adjacent, okay, which would be 1 over the square root of 3, but we don't like having the square root in our denominators, so we'll go ahead and multiply the square root of 3 in our denominator and in our numerator, and we're going to get the square root of 3 over 3. So essentially, we're trying to prove that a half divided by the square root of 3 divided by 2 is going to equal the square root of 3 divided by 3. Well, we can't really see that. So all we have to do from here is just go ahead and simplify. So because we're dividing fractions, we go ahead and do keep, change, flip. So keep 1 over 2, multiply by 2 over the square root of 3. We go ahead and multiply numerator times numerator and denominator times denominator. Okay, 1 times 2 gives me 2. And 2 times the square root of 3 gives me 2 times the square root of 3. We can go ahead and simplify this. The 2 cancels out with the 2. 1 over the square root of 3. And now because I don't like the square root in our denominator, I'm going to multiply the numerator and denominator by the square root of 3. And look what I end up with. 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is 3. So I just proved that my left side equals my right side. Okay, so here's another left side equals right side question. So we're trying to prove that sine squared plus cosine squared equals 1 when our angle is 30 degrees. So again, we're working with the 30-60 special triangle. In this case, again, we're working with 30 degrees. That's our relevant angle. Go ahead and figure out, first of all, what sine at 30 degrees is. Opposite over hypotenuse in this case is 1 over 2. This is my exact answer for sine at 30. Let's figure out cosine at 30 is adjacent over hypotenuse. So adjacent in this case is the square root of 3 over my hypotenuse, which is 2. But we can see from the question that it's sine squared and cosine squared. So all we have to do in that case is we have to write sine at 30, which we figured out is 1 over 2, and we're going to square it. Same thing with cosine at 30, which we figured out is the square root of 3 over 2. We're going to square it. And we're going to figure out, or we're going to prove how that equals 1. So we're going to see how the left side equals the right side. We need to apply this exponent to the numerator and the denominator. So we're going to have 1 squared over 2 squared plus the square root of 3 squared over 2 squared equals 1. 1 squared is 1. 2 squared is 4. Now I have the square root of 3 squared. When I square a square root, it cancels out that square root. Okay, so I'm just going to end up with 3 here. And then 2 squared is 4. Okay, And now we just have to add the fractions. Because they already have the same denominator, we're all good to go, and we just add the numerators. So 1 plus 3 is 4. That's over 4. And we know that 4 divided by 4 is 1. Okay, so we successfully proved that left side equals right side. Okay, this is our final question, and it asks us, find the exact area of triangle ABC. We're looking for the exact area of this entire triangle. Now, we know that the area of a triangle is base times height divided by 2. Base times our height and then divided by 2. But the thing is we're not exactly sure what our base is, and we're also not exactly sure what our height is. But using our knowledge about special triangles, because we can see that there's a 45 degree and there's a 30 degrees, so we know we're working with special triangles, okay? Using our knowledge about 30, 60, and 45 degree special triangles, we can actually figure out the values that are missing in order to figure out what base is, what height is, and then eventually what our area is. The first thing that we need to realize is that this tick here means that this side of the triangle is equal to this side of the triangle. Okay, and you'll notice that we have a 45 degree special triangle here. Okay, we don't know what the sides are equal to. Okay, but we do know that the hypotenuse in this case is equal to 6 meters. So special triangles, they don't always have to have the same side lengths. They just have to have the same ratios. And we'll get more into that later into the semester. All we need to worry about now is how are we going to figure out what the side lengths are, the missing side lengths. So this is an isosceles triangle, which means that the side lengths of this side length must equal this side length. Okay, that's what the two ticks mean there. And because it's a right angle triangle, we know that we can use something called Pythagorean theorem. We plug in what we know into Pythagorean theorem, which again is a squared plus b squared equals c squared. All we know right now is our c. Okay, all we know is that c is 6. But we also know that a is equal to b. Right? This side is equal to this side. We know that because of those ticks, which tell us that this is an isosceles triangle. So we can go ahead and instead of plugging a squared plus b squared, we can just do a squared plus a squared because they're the same side. They're the same length. So a squared plus a squared, because they're like terms, we can collect them, and that would be 1a squared plus 1a squared, which is 2a squared. 6 squared we know is 36. Now we just need to isolate for a. We'll divide both sides by 2 to cancel this out, and we're left with a squared is equal to 18. To get my final answer, or to get a by itself, I need to take the square root of both sides. A is going to be equal to the square root of 18. But going back to, I believe, Unit 2, we know how to simplify radicals. So we need to think of two numbers that multiply to give me 18, one of which is a perfect square. In that case, we know that 9 times 2 equals 18, and I can take the square root of 9. The square root of 9 is 3. I'm left with 3 times the square root of 2. This side length here is 3 times the square root of 2, which means that this side length here is also 3 times the square root of 2. So now I have my height, okay? My height is going to be 3 times the square root of 2. Okay, that's my height. Now that I have my height, I need to find my base. And we can see that my base is going to be 3 times the square root of 2, this value here, plus dB. So my base is going to be 3 times the square root of 2 plus dB, but we need to figure out what dB is. So I want you guys to take a look at this triangle here now. I'll redraw it. So instead of our short leg equaling 1, now it equals 3 times the square root of 2. We have a right angle triangle, we have an angle, and we have a side. We know that when we're given this information, because it's a right angle triangle, if we want to figure out what this is equal to, what this side length is equal to, we'll call it x, we can use SOHCAHTOA. So, just to make it easier for ourselves, let's fill out everything that we know about this triangle. If this is 30 degrees, we know that this must be 60 degrees. Let's work with the 60 degrees angle here. Okay, so we can fill that in over here too. This is 60 degrees. So this is our special triangle, our 30-60 special triangle. We need to use SOHCAHTOA in order to figure out this missing side. But normally when we use SOHCAHTOA, we write things as decimals. We write our final answers as decimals. In this case, we're not going to, because the question asks us to find the exact value. If we're looking at 60 degrees, we are given our adjacent and we want our opposite. Okay, we're given our adjacent and we want our opposite. So we know that we're going to be working with tan. So tan 60 is equal to opposite, which is x, over my adjacent, which is 3 times the square root of 2. Okay, before I solve for x, I want to figure out this exact value. So tan at 60, if we're looking at my special triangle, okay, so tan at 60 is going to equal opposite over adjacent. Okay, and in this case, that's the square root of 3 over 1. So I know that the exact value for tan at 60 is just the square root of 3. I've replaced tan at 60 with its exact value, which is the square root of 3. In order to get x by itself, right now x is being divided by 3 times the square root of 2, so I'm going to multiply both sides times 3 times the square root of 2. These will cancel out. Okay, so I'll be left with x on this side. And x is equal to 3 times, and remember when we multiply radicals, we multiply the two radicands together. So 2 times 3, which of course is 6. So what did I just find out? I just found out that x, this section here, is equal to 3 times the square root of 6. So now I know a couple of things. I know that the height of my triangle is 3 times the square root of 2. And I know that the base of my triangle is 3 times the square root of 2 plus dB, which we just figured out was 3 times the square root of 6. So now we have an expression for our height and we have an expression for our base. So we can go ahead and use our area equation, which is base times height divided by 2, to figure out what the simplified exact area is. So my base is 3 times the square root of 2 plus 3 times the square root of 6. Okay, that's my base, times my height, which is 3 times the square root of 2. And that's all divided by 2. I'm going to use distributive property to multiply 3 times the square root of 2 times 3 times the square root of 2, and then 3 times the square root of 2 times 3 times the square root of 6. Okay, so remember, when we multiply radicals, we multiply this number with this number, and then the radicand with the radicand. Okay, so we're going to get 3 times 3, which is 9. And then inside of our radical, we're going to get 2 times 2, which is 4. Now let's do the same thing with a 3 times the square root of 6. So this term here, okay, we multiply 3 times 3, which is 9. And then inside of our radicand, it will be 6 times 2, which is 12. Now we're almost done. We just need to keep simplifying our area. We can simplify this and we can simplify this, okay? So 9 stays the same, but the square root of 4 is 2. 9, again, here stays the same, but we know that 12, we can find two numbers that multiply to 12, one of which is a perfect square, and that would be 4 times 3. We know that 9 times 2 is 18. And when we simplify this radicand here, we take the square root of 4, which is 2, and we're left with the square root of 3. 9 times 2 is 18. And look what happens here. I can divide 18 divided by 2 and 18 divided by 2. So I'm going to be left with 9 plus 9 times the square root of 3. And this is my final answer. So this is the exact simplified area of that triangle. Okay, guys, so if you've listened this far, thank you. Please do your homework. I know that that was a lot to take in, but it's really just SOHCAHTOA, but based on these special triangles that we learned today. So please make sure that you memorize these special triangles, and I'll be back tomorrow. Let me know if you have any questions tomorrow, and keep practicing. Do all the homework. Okay, guys? Have a great rest of your day.